work today. Remember that one day a couple years ago where like okay, the whole city. Remember that one day like in March a couple years ago, the whole city flooded?
See, you're talking about a couple years ago. I don't remember what happened last.
Yeah, I have the mixes too.
Deep down, we're all voting for you.
I got the new and improved. Freaking the wall, freaking the wall.
Oh, yeah. That was funny.
Twilight glass.
You have an iron deficiency.
Bro, why is it not
stand up out
glass?
of bed to be like,
Yeah, I do that black one. I do that every day.
oh, yeah.
I do it when I stand up at
Do you actually inhale or whatever?
How's everyone doing today?
Yeah,
It's fine.
not the one that's like
Oh, 22.
Oh my gosh. Yes.
I was only awake because there were lightning strikes before that.
I didn't heard the thunder.
Yeah, I'm always
I
Alright guys, we're gonna get started. So what I want you to do is see if you can come up with the two ways that we've solved systems of equations using matrices. Today we're actually going to do a third way. This will be the last thing we do with matrices. And then we can have a test and all that good stuff. So you can look up in your notes if you want to, or if you just want to off the top of your head, you can.
Are we going straight into different calculus?
We're not going to do that, sorry. That'd be fun though.
I don't even know what that is.
So let's see if anybody came up with the two. Very good. Yeah, reduced row echelon form and Kramer's rule. Those are the two things we've used so far. So today we're going to be talking about inverse matrices. And we're going to use those to solve systems of equations. It's not any harder. It might seem confusing at first, but it's not any harder. But I thought these were kind of appropriate. This kid with like 15 calculators on his desk, like, work out some matrices here. And then this one, as we kind of like gone through matrices, there's a lot of different like terms that we use, like the determinants. We're going to use inverses. We're going to talk about identities, augmented matrix, all these different things. A lot of different operations we've done, and we haven't even like scratched the surface of actually what you can do with matrices. You can do whole classes on matrices. So a lot of these things we haven't even covered, but there's a million things you can do with matrices. We're just going to do the basics. Maybe someone in this class will take linear algebra in college, and that's when you do matrices. Engineering or computers, you might end up taking a linear algebra class. So go ahead and dive in here. The first thing, you don't need to write down the blue writing necessarily, but if we think about when we did this reduced row echelon form with our augmented matrix, we ended up, our goal was to get something like this, right? And then we have some numbers, like this. So we try to end up with ones on the main diagonal, oh, just forgot my zero, and zeros everywhere else. That was the goal of reduced row echelon form. And then these were the answers. Well, it turns out what we're actually doing is we're creating something called the identity matrix. This here is what's known as the identity matrix. Those ones on the main diagonal and zeros everywhere else. It's called the identity matrix. The identity matrix could be a 3 by 3 like this one. It could be a 2 by 2. But it looks like this with ones on the diagonal and then zeros everywhere else. And how we write this in math, we just use I for identity. If we put a little 2 there, that means a 2 by 2 identity matrix. So like this, which we've used. And then if you were to put a 3 there, obviously it would be a 3 by 3. Identity matrices have to be square matrices. So it'll always be a square matrix. That's called the identity matrix. And you could obviously have a 4 by 4, 5 by 5. In this class, you don't really go beyond the 3 by 3, but there is more that exists. Okay, so the question is, maybe what is the identity matrix? Why is it helpful, or what's something important about it? Well, let's say I do a little problem here. Let's say I have some matrix, let's say 2, 3, 4, negative 1. Then I multiply it by the identity matrix. So I would multiply this by this. Right. Anybody have a guess of what the answer is going to be? Well, let's do some of the math here. Let's start working it out. When you multiply, just a little refresher, you do row times column. So you do 2 times 1 plus 3 times 0. Then you do row times second column. 2 times 0 plus 3 times 1. And then you drop down to the second row. Row times first column. 4 times 1 plus negative 1 times 0. And then second row, second column, 4 times 0 plus negative 1 times 1. That's how you multiply. Anybody figure it out yet? Yeah, it's the same thing. So we actually end up with 2 plus 0 is 2. 0 plus 3 is 3. 4 plus 0 is 4. 0 plus negative 1 is 1. So you actually end up with the same matrix. If you multiply a matrix times the identity matrix. Just kind of like multiplying a number times 1, like 5 times 1 is 1. A million times 1 is 1. Right? It's called the identity property. So the same thing is true for matrices. It's just this, we have to multiply it by this matrix. And you're probably thinking like, well, why would we want to do that? It's a good question. So turns out we need this sort of fact in order to do what we call an inverse matrix. So we're going to come back to this fact here in a second. But an inverse matrix is the main way we're going to be solving these equations today. An inverse matrix, we use this notation right here. A with a little negative 1, that means the inverse. And you might recall seeing that when we did like F inverse, like inverse minus 4. Remember that? That's the inverse function. So A inverse is just A with a little negative 1 exponent there. An inverse will always have to be a square matrix. And this is an important property that we're going to use in order to solve the equations here. So what this says is any matrix A times its inverse, or the inverse times the original matrix, equals the identity matrix. So a matrix times its inverse equals the identity. And that fact is used a lot in like further matrix computations. We'll see how it's used today. But it's a really important fact to do with both identity matrices and inverses. That if you multiply a matrix times its inverse, you get the identity function, the identity matrix. Sort of like if you were to multiply like 3 times 3's inverse 1/3, okay? You would get 3 over 3, which is 1. So matrix times inverse is the identity matrix. So there are formulas to do these by hand. We're going to do just the 2x2 by hand, and then mostly going to be using the calculator. But I do want to at least show you how this formula works, and we'll do a couple computations. It's going to look more complicated than it is, but there's a formula that's kind of similar to like when we did determinants and Cramer's rule. So the formula for an inverse is if we're given a matrix, this is what we're given, matrix A, and we'll call the numbers A, B, C, and D. The inverse of this matrix looks like this here. You don't have to memorize this, but you probably will have to do it a couple times. So A inverse is 1 over A times D minus B times C times the matrix. Notice some patterns here. The A and the D switch. They switch spots. And then the B and the C just change signs. We're just going to flip signs. And A and D switch. And you might notice this down here. Anybody know what that is? AD minus BC? We've used that before. Yes, the determinant, right. So it's actually just 1 over the determinant, and then times that little pattern where we switch them and then change the signs there. There's a couple different ways you can calculate this, but this I think is the easiest way. So we'll take this approach. So it's basically 1 over the determinant. That's just going to give us a number, a scalar. And then we switch the A and the D, and then we change the signs to B and C. So let's try a couple. So we're going to find the inverse if it exists. It is possible for a matrix not to have an inverse. Really easy one here. So we're going to say A inverse equals 1 over, and then it's going to be 2 times 1 minus 1 times 1. You can obviously do that in your head if you want to set that out. And then we do matrix. We switch 2 and 1. Swap. And then these other 2 ones, they change signs. So then we're just going to be simplifying from there. So this is just 2 minus 1, so it's going to half times this matrix. And then one of the first things we do with matrices is scalar multiplication, which means you have a number times a matrix. Anybody remember what we do when we have a number times a matrix? Yeah, just multiply each number by, yeah. It's like distributed in. So then each of these get multiplied by half. So we get a half, negative a half. That's the inverse. Pretty easy, right? Let's do one more here. Take a second and try this one here. I don't know if I'll write out the formula. that's what you should get for your final answer there. Swap them, change the signs, and you'll be multiplying by a half. Now, if you were asked to prove that this is the inverse matrix, anybody have an idea how you could prove that this called this matrix A and A inverse are inverses of each other? Maybe use this fact here. What would be true if we multiply that? If I did A times A inverse, I should get the identity matrix. Okay. So here's the way you can prove it. Not that you'll be asked to prove it all the time. But using that fact, if you needed to prove it, you could say this matrix 6, 2, 5, 2 times this one should give me the identity matrix. You're right. So let's test it out. We do row times column. So 6 plus -5. And then we do row times column. It's going to be -30 over 2, so -15 plus 15. So I do this row times this column. +2 plus -2. This row times this column. It'll be -5 when you multiply these, plus 6. Then we simplify those. This is 1, 0, 0. 1. That would always be true. One more illustration here. We're not going to end up solving this whole thing real clear. When you try to solve this one, you would start with A inverse equals 1 over, and then it's going to be 3, right, when you multiply, minus 6 times a half, which is 3. And it doesn't really matter what's in here, because 1 over 3 minus 3 would be 1 over 0, which is undefined. This means the determinant doesn't exist, so that there is no inverse either. So inverse does not exist. Because we can't have 0 here. You would say that it's not singular as a technical term, but we're going to say it does not exist. So if you were to get that, that's the case. So let's actually use these inverses for something useful here. Let's take a look at some equations, system of linear equations. And yeah, it is kind of redundant to have 3 different ways of doing it. We're going to be using our calculator for this part, so if you don't have one, grab one. I'm not going to do this one by hand. So here's what we're going to do. We're going to write a matrix similar to what we did before, except we're not going to write an augmented matrix this time. We're going to write a coefficient matrix, so take the numbers in front of the coefficients. And we're going to call this A. So A is going to be 2, 1, 1, and 1. It's going to be one matrix. And then next to it, times, we're going to write the variables. The variables, we're just going to use a capital letter X to represent that matrix. And then we're going to write the variables X and Y and the order that they appear here. So x comes first. So we write x on top, y comes second, so we write that. And then set this equal to another matrix, matrix B, which is the solutions here at 8, 5. So this is what our equation looks like. Ax equals b. So A represents the coefficient matrix, X is the variables, and then B is the answers. Anything we do, like in algebra or anything, we always want to solve for X, right? It's always the goal, get the X for X. Alright, so we need to get rid of this A. So we always do the opposites to get to the other side. So what do you think is the opposite of A? A inverse, right? Yeah, what we've been doing, right? So A inverse, we multiply A times A inverse. What happens is we get the identity matrix, right? Show that. We get I. But we have to do the same thing on both sides. So we're also going to multiply the A inverse here. So when we do that, this sort of cancels the A, leaves us with the identity matrix. Here we have A inverse times B. The order does matter that you do that, because if you try to do it the other way, it's not going to work. So the order is important. And the identity matrix times anything, as we also showed, is just whatever that thing was, right? So we end up with just x equals A inverse times B. So to solve this equation that we have here, this is going to be true for any system of equations. We're just going to use this fact that x equals A inverse times B. And bring our x down. It's going to be x y equals. And then we're going to do A inverse times B. This we're going to do on a calculator. You could do it by hand, but what you would have to do is find the inverse of A, and then you would have to multiply that inverse times B. So we're going to do it on the calculator. You guys probably have enough of like those row echelon and multiplication and all that, so it takes it easy there. So what we're going to do, enter this in your matrices. So go over to second matrix and edit, first of all. Hopefully you can type those in. Make sure it's a 2 by 2. You're going to call this matrix A, and then you'll call this one matrix B. So you're going to enter 2 matrices, and you're going to enter matrix A, and you're going to enter matrix B. Go ahead and switch here. Okay, so now we got those entered. What we're going to do is we need to type in A inverse, but it's not obvious how we actually do that. What you're going to do is second matrix, select matrix A, enter on that. And then there's actually a little button that's a shortcut, if you can find it on your keypad there. Look for a button that would give us the little -1 thing. And do not do the like caret -1. Anybody see it? Right here. It's a little x with a little -1 there. So that's what we're going to put. You just do that little -1. So we got A and then -1. And then we just do times and then second matrix, select matrix B, enter, enter. And that's our solution. A inverse times B. So 3, 2 is our solution. And then these just match up across the rows. So x equals 3, y equals 2. We can just write as a coordinate pair, 3 times 2. That's it. So while it seems like there's a lot of complicated things going on, the actual solving of these is pretty simple. Let's try another one. When you do these, this is going to be what you need to write out though, so you got to write out this stuff here so that you know what you're doing. Let's try this one. So the coefficients go in our matrix A, 6, 5, 2. You need to make sure you write out the variables here, x and y. And then we have 1 for our answers. So then on your calculator, you're going to go to your matrix, edit those two. Here's your new matrix A, here's your new matrix B. And then I've showed you this shortcut for some other ones as well. But what you can actually do, once you got those updated, save it here some more time, is since we're going to do the same equation again, A inverse times B, you can just hit the up arrow twice and highlight that, hit enter, and then hit enter again. And it will just update. Since you have new values sorted for the A and the B, it will just update those matrices and then if you don't want to hit the second matrix, select it again. But you can just do that for all the problems. So then the next one, let's do one more. You're just going to go enter your matrix and then up arrow. Enter it. So last one here, go ahead and try this one. Then just type in your answer and got it. So it's looking like 1/2 and 2. Great answers. I'm going to give you guys the rest of the period actually to work on the assignment. It probably won't even take you the whole period, but since you need to use these calculators in order to do this for now, I want to give you that time to do the problems. So they're up here. They should be on Google Classroom as well. And I would actually just do these first ones first, just in case you don't get them all done. Do those first, because you need the graph calculator to do those ones. And then do 36 and 38, which are just couple of 2 by 2 inverses. But again, you should have plenty of time to get it all completed and got turned in. And then this pretty much finish up what we're going to do, and then so we'll start reviewing for chapter test.